Hi everyone, so we're gonna do the lab 8.4.2, the show IP route challenge lab. So for the task 1, examine the router outputs. So the step 1, examine the output from the router 1. So as you can see in the screen, there is the router 1 with the number sign, the show IP route. So the show IP route command is used uh, to show the router's routing table. So this is the list of all networks that the router can reach, their metric, and how to get there. If you reach in this challenge lab, so I expected that you already know the codes for the remote uh, networks. So, for example, the C that stands for the connected, the S that stands for the static, and the R that stands for the RIP, so and so on and so forth. So let's examine first. So the 172.16.1.0 is directly connected as the fast Ethernet 0. Then the 172.16.3.0 is directly connected as the fast Ethernet 0 1. So uh, there is the in this routing table entries that there are four automatically created networks here. So let's examine the output from the router 2. So the 172.16.2.0 is directly connected as a fast Ethernet 0 that's 00. So the 172.16.3.192 is directly connected fast Ethernet 0, fast Ethernet 1. So let's examine the output from the router 3. So the 172.16.1.192 is directly connected as fast Ethernet 0, fast Ethernet 1. And the 172.16.3.128 is directly connected as fast Ethernet 0, that 0, fast Ethernet 0. So that's so step 4, examine the output from the router 4. So the 172.16.2.64 is directly connected as fast Ethernet 0, fast Ethernet 1. And the 172.16.4.0 is directly connected as fast Ethernet 0 and fast Ethernet 0. So let's proceed to the step 5, examine the output from the R pipe or the router pipe. So the 172.16.1.32 is directly connected as fast Ethernet 0, fast Ethernet 1. And the 172.16.4.128 is directly connected as fast Ethernet 0, fast Ethernet 0 with. So let's proceed to the task to create a diagram of the network based on your router output. Step 1, draw a diagram of the network based on your interpretation of the router outputs in the space provided in the lab document. And the step 2, document the interface addresses in the addressing table in the lab document. So this is the diagram of the network based on my interpretation. So the serial 0, the 0, 0 of the router 1 is connected to the serial 00 of the router 3, and the fast Ethernet 00 is connected to the fast Ethernet 01 of the switch R1 switch with the network of 172.16.1.0 with 27 subnets, and the fast Ethernet 01 is connected to the switch with 172.16.3.0 with 25 subnets. So the serial 001 of the router 1 is connected to the router 4, the serial 000 of the router 4, and the serial of 001 of the serial 001 of the router 4 is connected to the serial 000 of the router 5. So uh, with the IP address or with the network of 10.10.10.12 and the serial 001 of the router 3 is connected to the serial 000 of the router 2 with the IP address of the network of 10.10.10.0. So here's the addressing table wherein the IP address of the interfaces and the subnet mask is made. So let's proceed to the task 3, build and configure the diagram using the packet tracer. So we're gonna configure the router 1. So this is the start of at a user mode where the prompt look like the greater than sign. So from there you type enable, move to privilege mode where the prompt looks like the number sign. So in privilege mode, you can show anything but not make changes. So next, type config terminal or confg as the shortcut. So to go to the global configuration mode where the prompt looks like router config, then the number sign that you can see in the screen. So from here, you can change the global parameters. Next, since the router's name is not set, let's configure this by typing the host name, the name of the router 1, and enter. Then after this, the router's name will set to R1. Then right after, to change the parameters on an interface like the IP address, we must go to interface configuration mode with the interface command. Just type interface and the name of the interface you want to configure. So F fast Ethernet 0 interface. Then just then after that, the prompt looks like router config F, then the number sign. Then type the IP address together with the subnet mask. So the fast Ethernet 0.0 is 172.16.3.1 255 255.524. Then type the no shutdown command. The no shutdown command enables an interface. So this command must be used in interface configuration mode. It is useful for new interface and for shooting. So just enter. Then after this, just repeat from interface mode and just type the next interface you want to configure. So next, we will configure the interface as Ethernet 0 and IP address 172.16.1. The subnet mask of then type no shutdown to enable the interface. Next, the interface serial 0, IP address and 10.10 subnet then no shutdown interface serial IP address and no shutdown. So let's take a look to check results. So, the fast Ethernet 0, the fast Ethernet 01, and serial, the 2 serial is correct. So we're gonna do, we're gonna configure the loop. So just type interface, loop back 0 or LO0 as the shortcut. Type the IP address 192.168.1. Submit 2.5.0. Then next is the RIP routing. Just type route RIP. The router RIP command places the router RIP command places the switch in router RIP configuration mode to configure routing information protocol routing. So the router RIP, type the network. So first is, second is the so 10.10 0 0 2 7 16 0 1 6 0. So the some so the main enhancement uh, of the version 2 command is the fact that it first sends the subnet mask with the updates. So hence, it is considered to be a classless routing protocol in the sense that is able to distinguish among different subnets. So the version command used to specify which RIP version to use, either 1 or 2. So we use the version 2, as you can see in the screen, because of its advantages. That version 1 doesn't contain, which I already mentioned previously. So the RIP version 2, this auto summarization behavior can be turned off using the no auto summary command. So just type accept. Next, we're gonna configure the static routes. Since the static routes of router 1 is not set, so just type IP route 7 and so let's take of the check result. So the static routes of the route 0 is figured. So let's proceed to the router 2. Since we already configured the router 1. So just repeat interface 172.16. Oh, subnet mask. Create the interface. 7 to the 16. Then we will shut down command. We will then the serial. And then we'll check. So let's look at the check results. Examine. So the fast pattern is 0, 0, then fast pattern is 0, 1, and the serial zeros is configured. So we're gonna configure the RIP that has been configured from the router 1. So with the step. So first is the router network. This network so 16, 0, 0. Some version. The check results. So we are already configured the router. The subnet mask is the 16. Shut down. Enable the interface. And the interface. Yes. 5, 2, 5, 5, function, Eleuterio, 7, 16, summary, so let's check. So the router 3 has been configured. So let's configure the router 4. Get the step and then the configure terminal, change the host name, router 4, interface, interface, 174.16, 5, interface, 1, IP address, so that's 16.2. And interface in the serial IP address. The no shutdown command to enable the interface and the serial IP address and the the router here. Network. Sorry. No. Some check result. I've already set the interface of serial 001 since the IP address is not correct. Then let's take a look at the check result. So we already configured the router 4. Then the last one is the router 5. So just repeat this step. In the pass Ethernet 0 alpha 0.1. Serial. So let's look at check result to see what we Steward. So the RIP and the version. Just type the router. Let's repeat the network together. Ah, summary. Forgot to check so to see. We already configured the router. So we already configured all the interfaces of the 5 routers. So let's proceed to the task 4 or the identify routing process. So the step 1, examine the R1 routing table. What are the IP addresses of the directly connected neighbors of the router 1? So I've already answered the question. So this is the IP addresses that the router 1 is directly connected to its neighbor. So first is the 10, the 10, the 10 dot 04, then the 10, the 10, the 10 dot 8, the 172 dot 16 dot 1 dot 0, the 192 dot 168, then which routes did Aaron learn from the directly connected neighbors? So all of this network. From here. I think it's all of the work. Then for the step to examine the R2 routing table, so how many total network subnet did R2 learn from its neighbors? So did R so 1, 2, so 13. There is 13 total networks or subnets that R2 learn from its neighbors. So where would R2 send packets to network not currently in its routing table and why? So the packets would be sent to the router 3 at the IP address of 10.10.10 .12 and .10.12. So this is the IP address that is the default route in the router 2 routing table. So what does the statement R0.0.0 that's 0 with 0 subnet via 10.10.10.2. So serial at the end of the router 2 routing table represents. So this is the default route to 10.10.10.12 at 2 default gateway or the default route. So for this step 3, examine the router. Which level 2 routes did router 3 learn from its neighbors? So all of this network. So from here, 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 from all of that uh, network. So which networks are directly connected to router 3? So this network that is, and one here. So, so which network is the farthest distance from R4 and how many hops away is it? So the 172.16.2, 172.16, that 172.16, the 2.0, 172.16, that 2.0. There are 3 hops away. So how many usable host addresses are on the network farthest from the R4? So this is there are 62 usable hosts. So how many routers must a packet pass through to get from router 5 to the network? So there are 4 router 5, so 1. So what is the gateway of last resort for R5 listed as 10.10.10.13 as the IP address? So it is the next hop address on the gateway of the last resort. So that's all for this topic, the Lab 8.4.2 Show IP Route Challenge lab.